6.4% of increase and decrease. In this section, we are going to calculate our percent of change, and our change can either be an increase or decrease. However, our general formula for calculating percent of change is this one right here. Percent of change equals your amount of change divided by your original amount. But how you calculate your amount of change depends on your situation. So your amount of change for an increase situation is calculated by taking your new amount and subtracting your original. So let's look at this situation here where last weekend you spent 2 hours online on Saturday, and then you increased to 4.5 hours on Sunday. We need to calculate our percent of change in our time spent online from Saturday to Sunday. Okay, we know it's an increase because we go from 2 to 4.5. 2 hours on Saturday is our original amount. 4.5 hours on Sunday is our new amount. So to calculate our amount of change, we take our new and we subtract our original. We get 2.5. Now we take this amount of change, 2.5, and we divide it by our original amount, right over here. And our original amount was 2. 2.5 divided by 2 is 1.25. In order for us to turn this decimal into a percent, we need to multiply by 100 or move the decimal place 2 places to the right. So our percent of increase in this situation is 125%. Okay, the other way change can happen is it can be a decrease. And in order for us to calculate our amount of change in a decrease situation, instead of doing what we did before, where we had the new minus the original, in a decrease situation, you take the original and subtract the new. Okay, so for this situation here where we have someone who, a softball player who has home runs every single year, we want to know the percent of change from 2016 to 2017. So 2016 is our original and 2017 is our new. Looking at these two numbers, 28 and 20, we are actually decreasing if we go from 2016 to 2017. 28 to 20 is a decrease. So to calculate our amount of change in a decrease situation, we need to take our original and subtract our new. Then to find the percent of decrease, we need to take that amount of change and divide it by the original amount, which is 28. And we find this actually ends up being 0.326. Okay, so I messed up there. It's not that. It's actually 0.286. Okay. So 8 divided by 28 is actually 0.286. And to turn that decimal into a percent, we multiply by 100 or move the decimal place 2 places to the right. So our percent of decrease is 28.6%. All right, and now you have some notes to write. You need to complete the percent of change generic formula and then complete the percent of increase and percent of decrease formulas. Now, the other thing we are going to cover in this section is percent error. Percent error is the percent that an estimated amount differs from the actual amount. Okay, so first thing you need to know is this right here is our percent error formula. In our formula, we have our amount of error divided by our actual amount. So here we have a situation where we're filling bags, 16 ounce bags with dog treats. And the acceptable percent error when filling a bag is 5%. And we need to determine that the 2 bags that we filled up, is their error or percent of error acceptable? So let's look at bag A. Bag A, 15. We wanted to fill it with 16 ounces, but we only filled it with 15. So our amount of error is going to be what we were supposed to fill it with minus what we actually filled it with. So we were supposed to put in 16, but we only put in 15, so our amount of error is 1. Okay, so 1 divided by our actual amount, the amount we were supposed to put in, 16, that ends up being 1 divided by 16, ends up being 0.0625. Okay, so to calculate our percent of error, we need to multiply that decimal by 100 or move the decimal place 2 places to the right. So we end up having our our percent error being 6.25%. And that is greater than 5%. So this one is not acceptable. Now let's look at bag B. Our amount of error is what we filled in, 16.5, minus what we are supposed to fill in, 16. So our amount of error is 0.5. So 0.5 divided by what we are supposed to put in ends up being 0.03125. Okay, and turning that decimal into a percent, it becomes 3.125%. So for bag B, our percent error is less than 5%. So this one is acceptable. All right, now it's time for you to write in your notes, and you only have to complete the formula for percent error. And of course, now we have 3 practice problems to do. All right, here are our practice problems, and I am going to help you through them, but not complete it 100% for you. I'll leave that up to you. So find the percent of change. Here we have a situation where we start with 50 people and we move to 70 people. Okay, so we start with 50, go to 70, so that is definitely an increase. So we want to use our formula for percent of increase, which is taking the new amount and subtracting the original and dividing that by the original. Okay, so our new 70 minus our original 50, all divided by our original 50. So our percent of increase in this situation is 20 over 50. Now it's your job to turn that fraction into a decimal and then into a percent. All right, in the next one, we have a situation where we're going from 300 miles down to 210 miles. 300 to 210 is definitely a decrease. So we need to use our percent of decrease formula, which says original minus the new divided by the original. Notice how that's different than our percent of increase, isn't it? Increase is new minus original. Decrease is original minus new. All right, so for this one, then that becomes the original is 300. Our new is 210 divided by our original. So this becomes what? 90 over 300. So I'll again let you turn that into a decimal and then into a percent. All right, moving on to the last one where we're going to calculate our percent error. We have a can of vegetable soup that is filled with, well, it's supposed to be filled with 10 ounces and has an acceptable percent error of 4%. But we found that our can only has 9.5 ounces. Does our can of 9.5 ounces have an acceptable percent error? Meaning, is our percent error less than or equal to 4%? Okay, so in this situation then for percent error, we have to calculate first our amount of error. What is our amount of error? What's the difference between what we were supposed to fill in and what we did fill in? 10 minus 9.5, 0.5. Okay. And then the other part of our formula for percent error says we have to divide this by our actual, the amount we are supposed to put in or supposed to have, 10 ounces. So our percent error equals 0.5 divided by 10. So you need to take that, complete it, or turn it into a decimal, and then into a percent. And then you compare this percent that you found. Is it less than or equal to 4%? If it is, it's acceptable. If not, it is not. And that is the end of 6.4.